Hello everyone, my name is Olectralab and welcome to the channel, welcome back to the channel, depending on whether or not you've been here before. And today I have a wee little tour of just a bunch of random stuff that I've made. It's logic gates, counter circuits, tripwire alarms, that sort of thing. Let me just check, make sure that the audio is actually working. We're recording? Yeah, we are, okay. Alright. So first, over here I have the counter timer switch of takes a really long time to get to the end. As you can see, this is a binary 25 piston matrix array here. And just for perspective, this takes a really long time to actually switch this gate over here off again. Reason being, it essentially has to count to binary 25, which means it has to go 0, 1, and then it has to go, it has to count all through the binary with however fast this clock works, which is currently operating at the fastest speed it can operate without glitching the blocks into place. And I figured this is just, I don't know, it's a cool idea for a time delay, like a really long time delay. Like if you need a trap to go off or something, or even just like a thing to get triggered after a certain time, you could use one of these because it has to count like 0, 1 from each one all the way up, and you can see these blocks are all being turned on and off, and each one of these has to be cycled. When you start off, it triggers all the way through, and then it like this has been running for probably half an hour and it still hasn't gone off, just because that's how long it takes to count all the way through. It's just a big old counter circuit. The next thing we've got over here is my tripwire alarm. I don't know if I got sound on. I'm not sure if I've got sound on. Just gonna make sure okay, we've got some sound. Hopefully this doesn't get horribly loud. But when I walk through here, it should trigger the strobe light and alarm thing here. I've got this nice little tripwire here. Just a cool circuit idea for protecting your your stuff. Maybe your base needs an alarm on it for some reason. This one is like a door, but it's a reverse power protected door, which means that pressing a button directly on the door or powering the door is not going to open it, but using the pressure plates or the selected buttons will. It's kind of a good thing, I guess, maybe. I'm not really sure where you'd need this, but it's a thing. The next thing I've got over here is just another regular alarm. It just toggles on and off using an observer clock. And over here I have just a bunch of random like logic gate related things that I made. So we started from the very, very simple, which is just like a NOT gate, which is just inverts the signal. And then we've got a buffer gate, which is kind of the same, but also kind of not. And then we have an AND gate, where both of the levers have to be on in order to trigger the light. Then we have an OR gate, so either or of these levers will trigger the switch. And then over here we've got a NOR gate, which is kind of like that, but the opposite. And then we have a NAND gate, which is like an AND gate, but the opposite. If both are on, then it just sort of turns off. Then we have a NOT clock, which is basically, it just means that the set output state is to true, indicated by the little bulb there. Then we just have a regular clock. This is actually the default one that you find in the Redstone handbook. And then we've got a triple NAND gate, which is only activated if you switch all 3 levers. And I thought it'd be cool to sort of do all the logic gates and then maybe build like a computer or some sort of lever-based puzzle out of them all. We've got a triple AND gate. Or is this a triple NAND gate? I forget. Next one we've got a triple OR gate, which is pretty similar in how it functions. Just all 3 levers will trigger it. And then over here we have the double latching quadruple OR gate, which is like the regular gate, except it's latching, which means... Uh-oh, what have I done? I think I broke it. I broke it! I've accidentally bud-powered this this piston here. But what's supposed to happen is definitely not that this is still powered. I'm gonna have to still work out the kinks of that. But the idea was basically that you've got to sort of double power this thing in order to unlock it. And then over here we've just got the basic D latch, which is just essentially a pulsed input converted to a constantly on input. And also it can hold like 1 bit, which is good. Then we have a 2 cycle, which means that you trigger it, and to trigger it again, you have to double cycle it. So it's just like a switch, but you've got to press it multiple times before the thing works. Here we've got a 9-bit counter. I'm not going to go through and actually no, I will toggle it a little bit because this one doesn't take too much. But you have to flick it 9 times in order for the thing to activate again. So this could be kind of useful if you're trying to make a puzzle where you just have to be really persistent. For example, this one right here, I actually counted how many times I have to flip the lever. And with 9 piston segments in here, I had to flip it 258 times in order to toggle the switch, which is really annoying. And I couldn't be bothered doing that, so I made this next one, which is the same thing except it has a reset button so that you don't have to actually count all the way through every single time. So if I flick this, it'll turn on, but in order for me to turn it off again, I have to flick this lever 258 times. So this could be like a cookie clicker game where you've got to, like, if someone wants to break into your base and open the door, they have to really stick to it and flick the lever 258 times. I don't know if we could actually do this. Can we do it? I have done it before. It's just that it took me like quite a few minutes to do it. Just because there's 9 was it 9-bit? Is that right? I don't know how you say it. Like it uses binary, except there's 9 segments stacking, so it's kind of like a factorial. I don't really know the right math word to use to describe the thing I'm doing, but there's probably words out there that describe it. I just can't think of them at the moment. Let's see, if we do successfully flick this 258 times, which, by the way, congratulations on still being here watching the video if I managed to flick it all 258 times to turn this lamp off. It should trigger. You can see that the bits are counting up here. We've only got like a few more bits to go. My finger's actually getting quite sore now. I'm gonna switch to spam click. I'm alternating between fingers now because they're getting very tired. But the idea is that this door... okay. Whoever's trying to break into your base, if you've somehow made the door like that you can only get in its adventure mode, they're going to be very sick of it, and they'll probably just give up, and they won't flick the lever enough times in order to close the switch. Come on, come on! We're nearly there. I know we're nearly there. I can't believe I'm actually going to switch and do this for okay, there we go. I switched it 258 times, and it's now reset. So there's your ultimate security system, is you have to play cookie clicker in order to get in. Obviously I don't want to do that again to reset it, so I can flick this reset button, which will make it so that the next input that I do will actually flick the switch. And this is just really good because I can press the reset button and then I can do it instantly. It's like a bypass to all of my problems. Can you imagine the frustration on my face when I thought that I had to click it another 258 times over here. Anyway, the next thing we have over here is a qubit. This is kind of like the same thing from before, except there's a 0, 1 state and a 0 and a 1 state. Don't really know how to describe that one. Then we've got a latching qubit with a 4-bit counter, an alternating current pulse clock. I called it that, but really it's just a comparator clock. it actually pulses so fast that the light just looks like it's constantly on. So I just called it an alternating current pulse clock. With dispensers, however, it will actually dispense items really, really fast at that tick rate. Next we have the dimmer switch, which is basically just a comparator loop. It's like a repeater clock except with comparators, and you can flick it on, and then when you flick it off, it will slowly count down dramatically. If you wanted to use this for some sort of dramatic reveal lights system, I don't know, you know how like you're watching a movie and there's like a warehouse scene and they flick the lights on and they come on like dramatically one after the other, like you could totally use that circuit to make that in Minecraft. Next we have a checkpoint relay. This uses the secret hidden feature of the repeater, that when you power a repeater sideways, this little what do you call it? It's like a bedrock slider will come out and it will be locked, which means that even if you turn the power source off, so now this repeater isn't being powered, because the repeater is being powered from the side, it will remain powered. But then when you flick this off again, it will die. The next one over here is the same system, but it's a double failsafe latch. I call it a double failsafe latch because in order for you to power the thing on, you have to flick both of these off and then disable the power source. So kind of like maybe you don't want someone to accidentally press the self-destruct button to the secret evil lair that you built. So you have a bunch of levers hidden around your base that you need to click all of them in order to activate the destruct sequence or whatever. Or it could just be for something else. Maybe you want a door that's just really hard to open. Or like maybe you could be building a puzzle room in a temple, or just any other structure for that matter, and you want them to have to find every single lever and flick it before it will work. Next we have got an observer clock alarm. It's just an alarm, but it uses an observer clock. Pretty self-explanatory. That's pretty much it. And these are the random redstone foundational tools, which I shall hopefully use to construct some kind of elaborate puzzle room maze from Maze Runner meets some other movie where there's lots of puzzles and it's scary. Anyway, thanks for watching, and congratulations if you made it this far in the video. You've unlocked a secret prize, hidden only for those who make it all the way this far in the video, and that is an invisible high five that you cannot feel from me. So there you go. High five. Thanks for watching. Have a lovely evening, and or morning, or afternoon, or whatever time of day it is where you currently are, and I'll see you in the next one if you stick around. Goodbye.